in Macs, game controllers are handled by the HI object, and this is for human interface device input, just sort of a general class of input devices like trackpads and mice and gaming controllers. The problem with this is that unlike MIDI, there's not really a standard for how these things output data. So one controller's D-pad is another controller's right-hand buttons is another controller's joystick buttons. So that's one issue. And then also when you take one controller and try it on a Mac versus Windows Big Sur versus Windows Snow Leopard or whatever, you'll get different indices. So these buttons will output different indexes for their identities. So in the Macs for Live device that I've been working on, that integrates these game controllers into Ableton Live, I've come up with a system of profiling. So these profiles just create maps for these different buttons to give them names that then we can sort of generalize in Ableton Live. So these profiles look like just basic JSON. So each button has some information in it that looks like this. So a button is identified by its index, and then it has a map name and a range, which can be 0 to 1 for a button, but as you'll see is actually 0 to 128 here in Windows. Joysticks can go from 0 to 255, or they can go to a 16-bit number of 65,535. So how do we do all with this? And that's what this attempts to do in the profiles. So let's take a look at how we create a profile. So we hook up our controller, and then we open up the HI object, and we can go to the help file and go ahead and start polling. So hit the poll button and then select your controller. In this case, I only have one. So that name that appears here, we'll want exactly that here at the start. So this is the key for pulling up all of this map information. And once we have that, we can just start taking a look and sniffing out all of the different controls. So here we have, I call these the color buttons because, they may have triangles, they may have circles, they may have colors. The colors don't necessarily follow a pattern. So there's lots of different opportunities for these. These are the right-hand color buttons. So the color button up is 51. So then we go to our text file and we find the color button up, and we would change that to 51. And then the range, we can see actually goes from 0 to 128. So we'll want to change that range to 128. We can also add another property, which we do use in the script, and we can call that button, and we can make that like a 1 or a true. That's kind of, you don't have to do that, but in this case, it's very helpful because we can distinguish because the range isn't 0 to 1. So then the other things we might want to do is to sniff out the joysticks, and we can see that these are sending on 8 and 20, and they have a range of 6,535 to 0. Some controls actually have a negative to positive range, which is kind of weird. Again, this is why people use MIDI, because it just kind of works. And we've got the joystick, so we would find the joystick right and change that to 20 and change the range to 65,535. And that is really all that is done with these profiles. There's some things that are more complicated. For example, the PS3 controller has motion. So when you plug that in, you'll get a lot of data coming out. So you'll just want to use like a route object, and then you can sort of take out those streaming things, and then you can look at the individual buttons. So you would go ahead and go route. And if all of the motion sensors were coming on, say 63, 64, and 65, you could just take that and filter out that data until you really wanted to use it. And then you could print this or just use the message box to view whatever was coming in. And you can start sniffing the numbers out that way. And then once this profile is done, you'll want to give it a name that is the name of the controller, and then the operating system, and then underscore profile.json is also helpful. And once that's in there, it can be used in the Max for Live device for game controllers.